Myself, Dr.P. Gopinath, Assistant Professor, Selection Grade, Department of ECE, KIT, Kalajar Karunanidhi Institute of Technology, Coimbatore. So today we are going to see the topic is B23 ECT 404 Digital Signal Processing. So in this subject, that is the first unit is a discrete Fourier transform. So in this Fourier transform consists of review of discrete time signals and system, then DFT and its properties, properties of DFT, FFT algorithms and its applications, overlap add and overlap save method. So initially transform, what is the use of Fourier transform? So here we are going to convert analog information into digital information. In this digital information, we need convert time domain into frequency domain. So that is a first transform is a discrete Fourier transform. So in this transform, convert time domain sequence is converted into frequency domain sequence. Here time domain sequence should be denoted x of n and frequency domain sequence is denoted capital X of k. So this is the formula for discrete Fourier transform. X of k that is equal to n equal to 0 to n minus 1. X of n e power minus j 2 pi n k divided by capital N. So here n value is 0 to n minus 1. Likewise k equal to 0 to n minus 1. This is DFT. Then next one inverse Fourier inverse discrete Fourier transform. So here frequency domain sequence is converted into time domain sequence. So this is the formula x of n equal to 1 divided by n summation k equal to 0 to n minus 1 capital X of k e power j 2 pi k n divided by capital N. Similarly k equal to 0 to n minus 1. Similar fashion we have calculate n value also 0 to n minus 1. So based on in this discrete Fourier transform and inverse discrete Fourier transform, origin is Fourier transform pair. So Fourier transform pair consists of time domain is converted into frequency domain. Then one more property we have included, that is a linear transformation. So in this transformation, instead of e power minus j 2 pi capital N, that is equal to Wn we have considered. So in this, it is called Wn is called Tudel factor. So here we have denote the Tudel factor formula. Capital X of k equal to summation n equal to 0 to n minus 1 x of n Wn kn, where k equal to 0 to n minus 1. And IDFT formula is small x of n equal to 1 divided by n summation k equal to 0 to n minus 1 x of k Wn power minus kn. For the limit value n equal to 0 to n minus 1. So this is the formula we have applied Tudel factor equation. The next one is a matrix equation. So in this matrix equation we have represent row and column wise. That is a n point DFT equation is that is a capital Xn, that is a capital N should be denoted number of rows and columns. Capital Xn equal to Wn, that is a Tudel factor when input value small x of n should be denoted input value. So this is the DFT formula. Likewise, IDFT formula should be denoted Xn, small xn, that is equal to 1 divided by n Wn star into capital X of n. So based on periodicity property of Wn, so we have obtained capital N value we have considered for n value is 8. So here Wn equal to e power minus j 2 pi divided by n is the formula. So here capital N value we have substitute n value is 8 e power minus j 2 pi 8, that is simplified e power minus j pi by 4. So here using cyclic property, so real part versus imaginary part. So in this real part, origin should be denoted here W8 power 0. Then after W8 power 1, W8 power 2. Likewise, we have to calculate W8 power 7. So here W8 power 0 equal to value is 1. So in this value, how to expand and means that is a e power minus j 2 pi divided by 8. So here nk value is 0. So that e power 0 value is 1. So likewise we have calculated W8 power 1 That answer is 0.707 minus j 0.707. That is 1 by root 2 minus j 1 by root 2. The W8 power 2 value is minus j. W8 power 3 value is minus 1 by root 2 minus j 1 by root. Then W8 power 4 value is minus 1. So this is applying cyclic property. So the similar fashion we have obtained remaining values. Then this is the value of W8 value. The next one is a W4. So in this applied total factor value W4 power 0 here real part versus imaginary part W4 power 0, W4 power 1, W4 power 2, then W4 power 3. So here W4 power 0 how to expand that means e power minus j 2 pi divided by 8 that is n value is 4 into nk value is 0. Then W4 1 value that is a minus j. Then W4 2 value is minus 1. Then W4 3 value is j. So likewise we have arranged the row and column wise. That is a number of rows. That is a n value is 4. We have represent 4 cross 4 matrix. So this is the total factor value for W4 value. That is a 1, 1, 1, 1. Likewise, that is a we are applying that is a W4 0, 1, 2, 3 values. Then you have now we have seen the one example problem that is a DFT of the sequence x of n equal to 1 minus 1, 1 minus 1. Using matrix method, this is the formula that is a xk that is equal to wn into xn. This is the formula. So here wn we have substitute based on total factor values. Then our input value 1 minus 1, 1 minus 1. After normal row and column wise multiplication and addition we have performed. Then output value of given problem x of k equal to 0, 0, 4, 0. Similarly, we are using direct formula. So you can see the third problem. Compute the 4-point DFT of the following sequence x of n equal to 1, 2, 3, 4. The DFT of the sequence that is a DFT formula here denoted x of k equal to n equal to 0 to n minus 1 x of n e power minus j 2 pi nk divided by capital N. Here capital N value is 4. So we have substitute capital X of k equal to summation n equal to 0 to n minus 1. So that n value is 4, 4 minus 1, 3, x of n equal to, x of n into e power minus j 2 pi nk divided by 4. Then after expanding the summation n equal to 0 to 3, so substitute instead of n 0, 1, 2, 3 we have substitute. So this is the general equation x of k equal to 1 plus 2 e power minus j pi k divided by 2 plus 3 e power minus j pi k plus 4 e power minus j 3 pi k divided by 2. So this is the general solution for the given problem. Then after we have expand that based on limit value of k equal to 0, 1, 2, 3. So k equal to 0, we have substitute the general equation. The obtained answer is 10. That is a e power 0 value is 1. Because all the value e power 0 value is 1. So we have directly add the given data. Then next one we have substitute k equal to 1. So here x of 1 equal to 1 plus 2 e power minus j pi by 2 plus 3 e power minus j pi plus 4 e power minus j 3 pi by 2. So here we have expand that e power minus j pi by 2. That is a cos pi by 2 minus j sin pi by 2. So after expanding, we have obtained the answer is 2 minus j. That is e power minus j pi by 2 value is minus j. Plus 3, then e power minus j pi value that is a minus 1. Then 4 e power minus j 3 pi by 2 we have expanded that answer is j. So final answer for k equal to 1 that is x of 1 equal to minus 2 plus 2j. Then similarly we obtain k equal to 2, the answer is minus 2. Then k equal to 3, we obtain the answer is minus 2 minus 2j. The final answer for this problem x of k equal to 10 comma minus 2 plus 2j comma minus 2 comma minus 2 minus 2j. So these are the problem based on discrete Fourier transform. Then similarly, we have see the next one, that is a IDFT related problems. Determine the IDFT of the 4-point sequence. Here frequency domain, that is a capital X of k should be denoted. X of k value is 10 minus 2 plus 2j, comma minus 2, comma minus 2 minus 2j. Here we are substituting the IDFT formula. X of n equal to 1 by n, summation k equal to 0 to n minus 1, x of k e power minus j 2 by nk divided by capital N is the formula. So here IDFT we have denoted 1 by n. Then here simplified equation, x of n equal to 1 by n x k into wn star k, or we have denoted x of n equal to 1 divided by n x k star into wnk. So after substituting the formula, apply the value k equal to 0, 1, 2, 3. We obtain the answer is 10, comma minus 2 minus 2j, comma minus 2 minus 2 plus 2j. Then after we have divide, that is a 1 by n value. That is a n value is 4. So we have substitute 1 by 4. So x of n equal to 1, 2, 3, 4 is the final answer. So these are the problems we have seen, that is a discrete Fourier transform and inverse discrete Fourier transform. So these are the transforms mainly, that is what are the applications we are utilizing means we have calculate spectral analysis, linearity, linear functions. So these then filtering operations we have performed. So these are the applications we are utilizing, that is a discrete Fourier transform and inverse discrete Fourier transform. Thank you.